Everyone, I'm Won Lee. We just started test hypothesis. Today, I'm going to introduce test statistic and rejection reason for H0. H0 is null hypothesis, and H1 is alternative hypothesis, right? So let's review a little about those two hypotheses. Alternative hypothesis is formulated as contents of new assertion or subject of interest or information differs from previously known contents. Those kind of thing, those kind of phenomenon is set as alternative hypothesis. Null hypothesis, on the other hand, is generally formulated to the contrary to the contents of alternative hypothesis, revert contents. For a simple example, there is a twisted coin. So we want to test hypothesis that probabilities of head and tail are not the same. Okay, that is curious. This twisted coin has same probability. Oh no, that's why we want to test. So null and the alternative hypothesis are as follows. H1, okay, alternative hypothesis probability of H is not equal to probability of tail. This is you focus on alternative hypothesis. Okay, let's see today then how to test hypothesis. We want to have a tool to test hypothesis. Since hypotheses pertain to the parameters of population, the most appropriate statistic estimator corresponding to that parameter obtained from a sample should serve as a mean of verification. Okay, that is a means of test. Therefore, there should be a single statistic for the given hypothesis, only one statistic. This is referred to as test statistic. So in estimation part, we call it best estimator. In hypothesis testing part, we call it test statistic. The name just changed, terminology changed, if different terminology. Okay, when the value of test statistic falls within a certain range, value of tested statistic falls within a certain range, the null hypothesis H0 is rejected, and the range is called rejection region of null hypothesis H0. Okay, let's consider example hypothesis testing for the bent coin, twisted coin. What do you think the tested statistic is? What will it be? How can you start to test? You may toss that coin, twisted the coin several times, and you may make decision, okay, the hypothesis from the result. The result obtained from tossing the bent coin should be the tested statistic. For example, let's say we toss 100 times. In that case, tested statistic would be the number of times has appeared. So what would the rejection region for the null hypothesis? Null hypothesis, remember, here had probability is equal to tail probability. Okay, this one is null hypothesis. So what would be the rejection region for this null hypothesis be? If the number of times has appears is exceedingly low or high, say 10 times, only 10 times, or 92 out of 100 tosses, then you may reject H0. It is not unbiased, fair coin. We would conclude that the coin is bent and the probabilities of heads and tails are not equal, right? It is very reasonable. So, in other words, the tested statistic in this case, x equal to number of times heads appear. And the rejection region for H0 would be x less than 50 minus some value, or x greater than 50 plus that some value that we have to decide this the value of this question mark. If the heads appear 52 times or 48 times, could we assert that probabilities of heads and tails are different? No. 52 times, even though that coin is really new, okay, fair coin, heads can appear 52 times out of 100 trial, 100 tosses, right? Not exactly 50, no way. So let's see example. For a bent coin, H0 is this versus H1. H1 is probability head is not equal to probability of tail. So it's not equal to, okay, in H1, we say it is a two-tailed test. We do not know less than or greater than, less than or greater than. Anyway, is not equal to. Then we call it two-tailed test. Let n equal to 100, 100 tosses. The test statistic number of times has appear. Rejection region for null hypothesis is x minus 50 minus question mark or x greater than 50 plus question mark. Because this one is equal means 1.25. That's why the value 50 is here, up here. Okay? Waiting time at a certain service counter. Second example. H1 is what? Mu greater than 5 minutes. We previously know the average of waiting time at the window is 5. But now that waiting time may be longer than 5. Okay, that is assertion. And let's see here, H0 is mu less than equal to 5. I told you this way, but you may use this kind of H0 because it is simple. It is easy to understand what H0 and or how the test hypothesis process is. Mu equal to 0. Okay? Test statistic in this case, H bar, because it is about mean mu, population mean mu. Best estimator is X bar, and test statistic is X bar. Rejection region for H0. Then X bar greater than 5 plus double question mark. Okay, some value. We do not yet. We do not know yet. Okay? And lifespan of a product is less than 2,000 hours. Then H0, H1 is here. H1, mu less than 2,000. It is a subject of interest. Okay? And mu greater than equal to 2,000 is contents of H0. But you may just say mu equal to 2,000. Right? Test statistic, same thing, X bar, because it is a hypothesis is about mean. The rejection region for H0 is just one side, okay? One way. X bar less than 2,000 minus triple question mark, some value. We have to, we will decide what this value is in this test hypothesis, okay? It is not that hard, I think. You understand H0 and the H1, and in order to test hypothesis, you need test statistic, and you have to understand what the rejection region of H0. Okay, this is it today. Thank you. Bye.